Welcome friends to the third lecture on levels of reliability. So, we are talking about lectures on module 2 on the online course on risk and reliability of offshore structures. Module 2 is focusing on reliability theory. In this lecture 3, we are going to talk about levels of reliability. So, in the last lecture we said that one should be able to identify the design point in addition to obtaining the reliability index. So, in statistical sense it means that I must be able to locate whether my reliability function or the performance function is lying in the safe domain or in the failure domain. So, analytical procedure of reliability modeling depends on two factors. Analytical procedure of reliability modeling depends on two factors. One is of course internal strength and resistance. It all depends upon what is the choice of the model. The choice of the model of the reliability study is going to depend on the data available or the data type which is required to produce the desired results. Now, in case of offshore structures, let us specifically down this model to an outcome. In case of offshore structures, you have got two set of outcomes. There are two outcomes. One, either success or failure. But interestingly, both are mutually exclusive and exhaustive. That is required for the data qualification. This is due to the fact that both of them are dependent on varieties of factors. So, they depend on variety of factors. Now, either success or failure, there is no other alternative. So, as no other alternative is feasible, one can write the following statement: since no other alternative is feasible, that is except success or failure, no other alternative is feasible, following equation is valid. That is, for a given system, probability of success plus probability of failure should be 1. Probability of success of the structure is reliability. Therefore, reliability is 1 minus probability of failure. It is important and interesting to note that reliability is expressed in terms of confidence built up on the system in a positive sense, and it is not index of failure. So, reliability index is index of confidence. And not index of failure. This is one of the better ways of looking at the failure theory as given by Cornell in 1969, as also mentioned by Denson in 1998. So, do not look at the failure, look at the success of it. There are different variables in reliability study. The variables are as per the choice, they depend on the problem or the nature of the problem posed. There is also a high exchange of interaction between the various specialities that provide additional information to the decision maker. There are various other factors which may also provide information and they also should be considered as variables. Okay? Let us say statistical analysis of the data. Let us say for example, the statistical analysis of the data conditions the data and of course the model, both, which will enable a predictable outcome. So, probability engineers propose the methods and tools for the calculation. Propose the methods and tools for calculation. Reliability engineer analyzes the failure modes, guarantees quality assurance, defines failure scenario, because he must either follow limit state of serviceability, ultimate limit state, etc. He can also look into their combinations. A structural engineer analyzes the response behavior of the system guarantees proper use of material and appropriate cross section and recommends. Mechanical models to predict the response so each of these players have a variety of variables. To deal with, okay. There is no commonness between them. So, they should give a meaningful output ultimately the decision maker considers the best possible outcome to reduce the risk in the process. As we said, reliability is looking at the success on the identified probability of failure scenarios. Then it is very important to know that reliability will also be circumscribed using a probabilistic approach. Therefore, probabilistic models should have a basic objective. They aim at the range of outcomes from the study for the given input data. Therefore, they should include the system randomness. We should not say system randomness, they should include the randomness of the data present in the system. Let us say like this. They should include uncertainties present in the system. Therefore, a probabilistic approach should aim at determining the probability of an outcome amongst the best possible outcome that can occur. So, probability can be expressed either in percentage varying from 0 to 100 or a number from 0 to 1. In engineering practice, it is very important that lower risk usually means higher cost. In engineering practice, we always believe that lower risk usually means higher cost. Hence, a common question which comes in reliability engineer's mind is, how safe is safe? Okay, at what level, or how safe is, let us say, safe enough. On the other hand, is there any acceptable risk? So, in offshore engineering, very interestingly, there is a common term called ALARP, as low as reasonably practical. This is very useful to define I should say to predefine acceptable level of risk. So, risk acceptance is a precondition which is imposed in offshore structural engineering domain, based on which safety is only designed in such a manner that system does not become safer than the pre-acceptable level of risk. So, level of acceptable risk is determined by regulatory agencies, it is prefixed. Of course, this is based on guidelines given by the number of researchers and reliability engineers who are involved in assessment. Based on their experience and expertise, the regulatory agencies advise a reasonable amount of acceptable risk to offshore industry, which is to be followed as a reliability or a safety practice. So, therefore, there is a clue, there is an indicator that the incremental risk should not be significant compared to other risks than that of the alarm level. The condition here is risk increment should not be more than that prescribed by alarm level. Let us say annual probability corresponds to an expected factor. Let us say it corresponds to an expected of safety. Let us say this expected factor of safety is E of f. Of course, the probability of failure annual will be corresponding to this, because this is prefixed as per the alarm level, which is of course a variable now. And this will be expressed in terms of standard deviation of the factor of safety. Let us say if factor of safety is assumed to be normally distributed, then reliability index beta is expressed as the expected value of factor of safety minus 1 by standard deviation of this. Let us try to plot the relationship between reliability index and probability of failure. Let us take the reliability index plot in the x axis and probability of failure plot or the value variables in y axis. Let us say it varies from 0, 1, 2, 3, 4 and 5. Let us say this value is about 10 power minus 7 and this is about 1, that is 10 power 0, which is 1 and so on. So, friends, please pay attention to the sketch or the graph shown in the screen. You can see here it is a typical relationship curve which is connecting reliability index to the probability of failure. So, one can see here, for a system to have very high reliability index, the probability of failure will be as low as 3×10⁻⁷. So, we call this as high reliability index qualitatively. Whereas, if the reliability index is closer to 1 or whose probability of failure is closer to 0.1, then we say the system is hazardous. So, one can see different category of hazardous, unsatisfactory, poor, below average, above average, good and high. So, system is generally classified as high, good, etc. based upon two indices, one either based on reliability index or based on probability of failure. However, these two are connected by this relationship given in equation 1. So, one can qualitatively say whether system is, the reliability index of system is high or hazardous based on the number simply varying from, indicated from, let us say 0 to 5, or based upon probability of failure which varies from 1 to as low as 10⁻⁷, as seen in the figure. If you look at the structural design of offshore structures, the design essentially relies on deterministic analysis initially to arrive at appropriate cross sectional dimensions of the members to withstand the encountered forces. It is a well known fact that the material properties and the encountered loads in offshore structures are clear victims of uncertainties. We have already seen that in various examples. Loads are highly uncertain due to their mean of occurrence, and material are highly uncertain due to the significant degradation in marine environment. Let us say offshore structural system subjected to loading environment in marine environment, let us say environmental loads in marine environment. System of course made of members as cross section dimensions and material. Let us talk about material characteristics. We already know there are a lot of uncertainties in estimating the material characteristics for the design purposes. One could be material degradation due to aging, due to corrosion, aging, etc. Loads also have uncertainties. It can be due to the mean of occurrence, return period, the design life of the structure versus the chosen spectrum, etc. There can be many factors. Okay, you got a good reference. Please, you can refer to my own textbook, Offshore Structural Engineering, Reliability and Risk Assessment, CRC Press. I have listed this ISBN number etc. in the reference of NPTEL website. You can look into more details. What are those factors which can affect or contribute to uncertainty, especially in the material front and in the loading front. Therefore, we have variations coming from the material, as we just now saw, can also come from the loads. In addition, can also come from structural forms, that is the geometric forms. Because this is usually based on sound experimental investigation scale model. So, the variations which arise from the structural form are very marginal. So, they are not significant because people suggest structural forms, detailed, experimental, numerical and analytical validations. Okay. Therefore, the variations in the structural form will be very marginal when compared with that arise from material and from the loads. Therefore, it is important to introduce how, now the question is how to account for these variations. So, therefore, it is important to introduce some index which can account for this variation. Therefore, safety index should account for such variations. Since all variations cannot be accounted in one factor or one index, people have used what is called partial safety factors. Partial is related to the meaning that the safety factors accounting the variations are not complete. A single factor cannot account for all variations. So, people said it is partially accounting for. So, there are safety factors for both, which is seen in the international codes, both material and that of the loads also. One is gamma m, other is gamma f. M stands for material, F stands for forces, let us say loads. But please understand, using partial safety factor does not guarantee an absolute measure of failure of probability. Okay? That is very interesting. So, using partial safety factor does not ensure correct estimate of probability of failure. Okay? It is a very interesting statement. The Clevenson 1981, Frudenthal 1947, Matheson 1988. Many people supported this statement, 1986 etc. References can be seen in the NPTEL website for details. Having said this, one should be able to account for these variations in the reliability analysis. Therefore, let us say various levels one can look at reliability. There are different levels of reliability analysis which can be used in the design methodology. They all depend on the importance of the structure. The term level is characterized by the extent of information about the problem that is used and the data that is provided. So, they can be grouped in 4: level 1, level 2, 3 and 4. There are 4 levels of reliability. Now, the fundamental question comes, how this grouping is done. So, grouping is done or level of reliability is chosen on the basis of degree of sophistication applied to apply to the treatment of the problem. In general, that is what it is. We will see specifically what do they mean. Level 1, people use appropriate characteristic values of random variables. Characteristic values of random variables are used in level 1. They are used as partial safety factors in the design. For example, LRFD, that is load resistance factor design method, is a classical example of first level reliability analysis. The main objective in this level is, in this level of reliability, is to minimize the error between the target value and the design deviate. Level 2 employs two values of each uncertain parameter, uses two values of each uncertain parameter. What are they? Mean and standard deviation. For every parameter, these two data are used to model the reliability problem. Of course, they will also be supplemented by the correlation between the parameters. Talk about level 3. This method encompasses the complete analysis of the problem. It involves integration of multi-dimensional joint probability density function, or integrated over the extent of safety domain. Reliability in this case is expressed in terms of reliability index and failure probability. In level 4, the economic importance of the structure is also included. So, the reliability estimate will converge to become risk estimates as well. It involves the principles of engineering economics under uncertainty. It considers cost and benefit of construction, or even repair. It considers problems associated to maintenance. It considers consequences of failure without not even stopping at the stage of probability of failure. It also assesses the consequence of failure, and of course the interest on the capital investment. As said by Yasari et al. 1967. Sensitive projects like offshore structures do fall under this category. Other structures could be nuclear power plants, transmission towers, highway bridges. They all fall in level 4 reliability study, where one has to look into the cost and the benefit of repair or construction, the level of maintenance. One should also look into the consequence of failure does not even stop estimating the probability of failure. So, it is essentially converging towards risk assessment. So, friends, in this lecture we understood various factors or various players in reliability estimates. We have tried to understand the connectivity between the probability of failure and reliability index and converting the whole mathematical scenario into a relative qualitative statement saying high, low, etc., using a graph as we saw during the lecture. We have also understood different levels of reliability, what are the players in each level, and we realized that in level 4 the engineering economics is encompassed in the reliability study. Therefore, it is anyway converging towards what we call risk assessment. Further details we will see in the next lecture. I hope you would have gone through the lecture notes of previous module and you are following this as well. I would urge you and request you to look into the references cited during the lecture for your additional reading. Thank you very much.